Okay, so for this first page, what you're doing on each one of these is you're solving the equations, you're going to write out what the solutions are, and then you're also going to write out what it looks like in its factored form. All right, so there's a couple of ways you can do this. One is you can recognize that x squared plus 4 fits this factor pattern right here as the sum of two squares. All right, so in this case, a squared is equal to x squared. So what that means is that a is actually x, and 4 is b squared. So b is going to be 2. So when I substitute this into that formula there, I'm going to have a, which is x, plus bi. So b is 2i, and then I'm going to have x minus 2i. Okay, now that's factored. Right? So I can take each one of those factors, set it equal to 0, and get the solution. So minus 2i minus 2i, and I get x equals negative 2i. Okay, that's one solution. And then the other solution is going to be x minus 2i equals 0. And I get x is positive 2i. So my solutions are plus or minus 2i. Okay, in factored form, we want these things to be linear factors, and both of these are linear factors because the biggest exponent on them is a 1. Okay, so in factored form, that's simply going to be x plus 2i times x minus 2i. All right, to solve this next one, this is a quadratic because the largest exponent is a 2. Okay, so that's telling us that we can use the quadratic formula, or if it can be factored, we can solve it by factoring. Okay, so I'll demonstrate both. If we were going to use the quadratic formula here, my a value in my formula is going to be 3. So a is 3, b 16, and c 5. All right, so I've plugged those values into the, all right, so I've taken these coefficients, plugged them into the quadratic form. Okay, so I've plugged this into, taken these values, this is my A, B, C, plugged it into the quadratic formula, okay, did the arithmetic, and got negative 1/3 and negative 5 as my solutions. Okay, now to get it in factored form, when you set up your factored form, you always set it up as x minus x minus. Now I plug in those roots, negative 1/3 and negative 5. So what this ends up becoming is x plus 1/3 and x plus 5. So here are my roots. Here is my factored form. Okay, now you'll notice over here, I added the factoring method. So the factoring method for this would be, since this has a leading term, I take that leading term and I multiply it by 5 to get 15 right over here. Okay, then I want to find a pair of numbers that multiply together to be 15 and at the same time add together to be 16. So those two numbers that work are 15 and 1. Okay, then over here I use what's called a box method to factor these types of quadratics with a leading term other than 1. So in the upper left box, I put my constant. In my lower right box, I'm sorry, that's not the constant. This is called the leading term. The quadratic term goes in the upper left. The constant goes in the lower right. And then these two numbers that I found, the 15 and the 1, those go in these this diagonal. Okay, then I go through each row and column and I write out what the GCF is, the greatest common factor. So the greatest common factor of 15x and 5 is 5. GCF of these two is x. GCF of these two is 3x. And the GCF here is 1. So then these two terms here give me what my factors are. X plus 5 is 1, and 3x plus 1 is the other. Then I set each one of those equal to 0, and I solve it. And I get the roots, -5 and -1/3, just like I did over here. So it's just another way of doing it. All right, so this next one, even though it's not a quadratic, it has the same form of a quadratic, being that that exponent is 2 times that exponent. So what we did on these types is we used a method called U substitution, where I let U equal x squared. So then I can rewrite this as U squared. That would be the same as U squared would be the same as x squared squared. So U squared is equal to x to the 4th. So this is U squared plus 13U minus 48 equals 0. Then I could either use the quadratic formula on this, or I could factor it. In this case, I'm going to go ahead and factor it because it looks like its factor is pretty easy. What two numbers multiply to be -48 and at the same time add together to be 13? Right? And that would be 16 and -3. So then I can factor this into U minus or plus 16 times U minus 3 and then I can set each one of those equal to 0. So U plus 16 is 0. So U is equal to -16. And then over here, U minus 3 equals 0. So then U is equal to 3. Then at that point, I'm going to replace the U with x squared. So now I get x squared equals -16, and I get x squared is equal to 3. Right? When I take the square roots of both sides, I get, the x is equal to, that's -16, so that's going to be plus or minus 4i. And then over here, I'm going to have x equals plus or minus the square root of 3. Okay, so I'm going to have 4 roots because that's what that exponent tells me I should have. And my roots are going to be, 2 of them are plus or minus 4i, and the other 2 are plus or minus root 3. Okay, now in factored form, remember when you set up factor form, it's always minus. I'm going to have 4 factors. Okay, x minus x minus x minus x minus. And now I put in my zeros. So negative 4i, root 3, and negative root 3. So I can rewrite these double negative ones as a plus. It's my factored form, and here are my roots. All right, now we've got a cubic, and we want to find its roots, what makes it equal to 0. So the first thing it says is we can find one real 0 by graphing. So when we graph that, we get a real 0 is x equals 5. So I already know one of the roots is x equals 5, and one of the factors is going to be x minus 5. Now I take this root and I divide it into this quadratic here. And I'm going to use synthetic division to do that. So if you remember what we did here, we brought down the 1. And then I went 5 times 1, 5. Add those up, 0. 5 times 0, 0. Add those up, 2. 5 times 2, 10. Now, it looks like I made a typo. This 10 should be negative. So now when I add those, I should get 0, which is what should happen. Okay, so now these are the coefficients on a polynomial that has a degree that's 1 less than x to the third. So that's x to the second. So the 1 is the coefficient on x to the second. The 0 is the coefficient on x to the first. And the 2 is my constant. So that quadratic is x squared plus 2. Right? Now, I want to solve that. There's lots of ways you can solve it, depending on what kind of quadratic it is. So this one, I really don't need the quadratic formula. I could do it, but there's simpler ways of doing this. I could factor it like I did problem number 1, or I could just solve it by subtracting 2 from both sides. And I get x squared equals negative 2. Then I take my square root of both sides. And I get x equals, and this would be the square root of 2i plus or minus. Right? So that's my other 2 roots. And so one of these is going to be x minus root 2. The other one's going to be x minus negative root 2. And this will turn into a plus.